Yeah, I'm Dave Grant, CEO of PickNik Robotics, and Dave Coleman, many of you know, is founder of PickNik Robotics and really deserves all the credit for creating the great company it is today. It's just funny to me walking up here. It's like sometimes people get us confused. They're like, I talked to Dave from PickNik, which one was? But if you look at the two of us side by side, like which one do you think is a business guy and which one do you think is a cool kid, right? So that's all you need to know right there. So what we're going to do is I did a presentation on Monday, and so that was really kind of more of a high level, almost executive level presentation, talking about this opportunity to do much more robotics and automation in the automobile manufacturing industry. So I'm going to use a few of those slides in terms of setup, and then that didn't go super deep on technology, so that's what I'm going to hand it off to the smart kid over here, which is going to go deeper into tech, right, and kind of explain that. So we got a lot of slides too, so we'll go really quick. But a little background on PickNik, if you're not familiar with the company, Dave founded it back in 2015, purely at that time, to do consulting and software engineering for open source projects, obviously ROS and MoveIt open source, right? So built up a great team and et cetera. And then a few years ago, also added MoveIt Pro, which is a commercial oriented software that we're really working with today. So again, as I mentioned, I'm going to talk about automotive assembly. There's something I call a little bit the automation paradox, right? In terms of if you think about it, what I was educated by our customer, BMW, is the body shop and the paint shop. And by the way, how many people do we have in here that work with the automotive industry? I know we have Magna over here. Do we have any GM people, right? So, et cetera. You might be familiar with us. So as I got educated, when you see all the robots working in manufacturing and automotive, right, they generally work in the big pictures in the body shop and et cetera like that. So the big frame of the car, the body panels, et cetera, and that's been done. And this folklore is that GM bought the first robot in 1961 or 1962. And so that whole area has been automated and working really well. But to me, it was this paradox because there's literally thousands of other use cases that create this long tail, which in totality is a bigger opportunity, but it's not been automated, right? And so I kind of started digging in, well, why is that? What's the cause of that? So if you think of the lower left-hand corner, what we had was, I would say, conventional robotics, and that was been able to traverse over to the right-hand side in terms of the body shop is traversed, I should say, the right-hand side with conventional robotics to do what I call cost-effective scalability, right? Up on upper left-hand corner, a lot of those people in this room have been doing advanced robotics for many years, right? And that's what's required for general assembly, pre-assembly, all these other different tasks, whatever. But there's not been a high amount of penetration in the industry with that. And so I was like, well, why is that? So if we kind of contrast what happens in the body shop and what happens in assembly, the body shop in terms of, I call the technical factors, right? Like you have things like it's become highly, highly structured. These automobile assembly lines, even if they kind of curve, they can be as much as 8 miles long, right? So what you're really doing is taking the car parts as they get assembled and bringing them to the robot in these highly structured way, right? They also have very limited part variation. So the body style of a car, can last as long as a dozen years, hardly ever shorter than a half a dozen years, right? So you have limited part variation, a lower number of parts, you have discrete operations, et cetera, like that. And then from economic side, you had much higher labor costs, right? Lifting up the frame of a car when it was done totally manually could take 3, 4, 5 people, et cetera, working around that. You had a lot of people getting injured, right? So that's obviously not good for the employees. It's also not good for the companies in terms of health insurance costs and people going out of work, right? But you also did have the opportunity for quality gains. So all these factors made it really much more possible and easier to take conventional robotics and automate the body shop. But when you looked at general assembly and the different parts within there, you have much more task complexity. What we as humans, do and take for granted, grab this small part, put it together with the next part, even wire assemblies and things like that, which people can be taught to do, was very difficult to get conventional robots to do. And so all these things in terms of dexterity limitations of robots, sensing deficiencies, et cetera. You also have much higher mix and lower volumes in this side of the house, right? And so that goes back to many different things and cost factor, one of which being programming. So in the body shop, if it took 6 months to program that all and the structure of the environment, then you had 10 years to pay that off, that'd be okay. Many times in general assembly, these things will change, within 6 months or a year, year and a half, right? And so if you are not able to reduce the cost and increase that ROI in a shorter period of time, you're not going to be able to bring the robotics there. And also much more of this side of the house has been, outsourced. So you're not necessarily producing in the high labor, countries like the US and Germany, et cetera. You've been able to push this offshore, right? So the net of this, though, what we're going to talk about is the technology enablers now, which are going to allow advanced robotics actually to finally kind of slay this dragon. Everything from the AI-enabled things, machine learning, et cetera, like that. Also, a big part of this is all the hardware choices available today. Because of ROS and ROS-II, we're getting much closer to a plug-and-play environment, which is super important to be able to bring these different components together to create optionality and choices, but also the hardware is coming down in cost. So this is, I'm not an expert on automotive. There's probably people in the audience who know this better than I do, but just kind of these are some of the things like parts kitting. This doesn't happen only in manufacturing. Parts kitting can also be like in the third-party logistics, but it really hasn't happened too much in manufacturing. Sequencing. Sub-assemblies, right? All those bigger parts to go inside of a car. It could be a seat, a dashboard, etc., like that. And then installing those in the car. Something I was just educated on: powertrain marriage, right? Where you take the powertrain, obviously, that drives the power to the car, and marrying that together in with the body, right? And automating that. There has been some automation there, and also in glass and trim, but there's more opportunities there. And I think the holy grail, or kind of the ultimate, would be able to do this wire harness assembly. I know every year there's an organization, I forget the name of it, but sponsors, you know who it is? That sponsors a competition about who's going to get the closest to be able to do this. They were educating me on that over at the European Robotics Forum. Right. Yeah, so this is a case study we do with BMW. Dave, how do I get that to play? Oh, it's just, okay. See, I'm not technical. I can't play videos. Right. But you'll just see this kind of play in the background. So they did allow me to take a video within their lab. They don't allow any pictures or videos. They give me a nice plant tour. So this is over in Munich. The Next Gen Robotics team over there is doing some really great work. And these guys, they love ROS and they love MoveIt. So fortunately brought in there. So this is doing what they call a chaotic pick and place. Right, so you saw the bin. I'll let you play it again. So it has to go in. You can see how the parts are all in different order, etc., like that. This particular part also, since they're using a suction gripper, they can't pick over one of the holes. They can't pick on a contour. So it's got to identify that, and then it actually goes over and does what they call a precise placement. So it's a simple example of how you can actually begin the assembly process. Right, so that's sort of the technology side, but also from the cost perspective, right? They're able to use a much lower cost camera than they used to. I showed this video to another car company, and the guy was like, "Well, yeah, we were doing that like 3 years ago." Well, then he had to confine that the vision system that he was using was like a $50,000 vision system. I said, well, this costs nowhere near that. So this whole setup, it depends on which you're using, et cetera. But this whole setup is probably hardware-wise, in the $60,000 to $70,000 range, right? So that's where this becomes now possible. Start automating some of these things we're talking about. I'm not advancing here. Dave, I think I can figure this out. I got it. So what they did is actually, this was with a different part, but there's still a BMW. What they did, which is what we advocate, is begin your development in sim mode. Actually stay there as long as you can. Then a lot of advances in simulation. I know what we've incorporated is a physics-based simulation. And so it's a lot more accurate and really shrinks that gap between sim and real. And so you can see that here. I think Dave's out and Dave's in. So take it away.
Thanks, Dave. It's been really great having Dave Grant leading the company. My background, I have a PhD, so being more technical again has been really nice, and having this business experience. I want to give you a few updates on MoveIt, MoveIt Pro, ROS, and what we're doing there. This is the ROS Industrial Consortium. But tying back what he was saying, it's really exciting to see large production systems and companies, like larger companies, using ROS in reliable ways. And it's something we've been working on for years. I want to mention that, so MoveIt Pro is a robotics platform. Particularly, it uses ROS through and through, so it's quite closely married to ROS. And we're using it across so many different applications. We have plans to put it in space. We put it underwater for oil and gas industries, construction, you name it, like all over the place. And this is a newer kind of layout of how we're thinking about the product offering. And it really spans 3 different categories. So there's lots of runtime autonomy, which is what maybe you classically thought of as in MoveIt motion planning in terms of global motion planners, local motion planners, inverse kinematics, real-time controllers. And then now we're layering in what I call ML subsystems. So models that are for a more expert system, and I'll get that in a minute, as well as we have some in beta, some of these end-to-end ML approaches that there's a lot of hype. Don't believe everything you hear in the marketing, but we're also having some prototypes there that we're excited about. And then the 2 other areas of MoveIt Pro is, as other Dave was just talking about, lots of different simulation capabilities around continuous integration, testing, creating synthetic training data with simulation, as well as just like, it's really incredible how small the sim-real gap has gotten for us. And we can spend weeks developing an application totally in sim, and then a day or 2 tweaking it to run on hardware. There's not that many parameters we have to deal with, assuming that you have a good ROS driver. That's always a prerequisite. And then finally, the user interfaces, we're big fans of behavior trees, so that's an optional piece, as well as lots of debugging tools. In terms of AI, this is a talk I gave 2 weeks ago at Boston Robotics Summit, so this is just a snippet of a lot of what we see on the expo here at Automate. Still what I call traditional Gen 1 industrial automation, a lot of waypoints, a lot of teach pendants, and it's great. It's going to continue being a very reliable way of solving things, but we are seeing more and more vision systems, and so I'm going to call that Gen 2. And that's the world that I kind of grew up in from Willow Garage. I was an intern there, involved in the inception of the MoveIt project. And Willow kind of pushed forward this Sense Plan Act paradigm that's still with us and going strong today. I don't have time to go into detail of all these, but I could speak so much more about how dynamic motion planning, collision aware, collision checking, those are still things that there's so much more traction that we could use it and apply it. And applying those things, where it's like tip of the iceberg of what we could do there beyond traditional industrial automation. So even though AI is getting all the buzz, we really believe at PickNik that this Gen 2 stuff is so much more reliable and verifiable, safe. And so don't just throw all that out is kind of our belief. And we may be proven wrong in 10 years from now, 5 years from now. I don't know. I believe it's going to be a combination, a hybrid approach. And then something that has really proven itself is these ML perception subsystems. So transformers for grasping, transformers for segmentation, pose estimation. Those are fantastic. It still matters you have good data going in so you get good results. And so it's still very fast paced how to apply this effectively to robotics and train the models in a way that can evolve over time as your products change or your processes change. And then finally, the buzzword of the day, end-to-end models. PickNik has been experimenting with diffusion policies, and it turns out we can use all of the capabilities of MoveIt and ROS to create a bunch of synthetic data using Oracle policies. So that doesn't require teleop. You can just use these expert systems that we've developed to then train an AI model on how to do it in a more general way. So that's an exciting approach. Oh, I had this whole slide I was holding back on you guys. Yeah, so to kind of reiterate, our approach is this hybrid system. On the left is called deterministic controls, or the Sense Plan Act controls. And those really are a nice safety system on top of these 3 different types of ML approaches that we're using. And our approach is we orchestrate all of this through behavior trees. And that allows us to have the kind of model-based design to really understand and debug and introspect what it is the AI is doing and how we can make sure that it's staying within safe parameters. Here's two options that we offer, and the way we're looking at AI is there's pre-built models. There's tons on the internet now. We have a handful of them integrated into MoveIt Pro. You can download more from places like Hugging Face, or the newer thing I was describing is these end-to-end models. And so having a whole pipeline is something that we're building out right now in our capabilities, and our customers are very excited about this. And then, like I mentioned, it's all orchestrated behavior trees. So this is kind of a little GIF showing how this low code, you can drag and drop and build all this. And so we actually have the ML models as nodes or blocks in this paradigm. And so it will step through there and give us the output of like, this is the 2D bounding box or a mask. This is the 3D. So then we can translate to 3D using point clouds or getting the poses for the grass planters to use. And then to go a layer deeper, we can also use LLMs to create the behavior tree. So you have AI, verified system, and AI. It's like this layered cake. And this is showing a lot of promise. Still a little more experimental for us, but just giving it English prompts or any language and converting that to it building its own applications. So we're really excited about where all this is going. And again, this is all built on ROS on top of that. So I just wanted to quickly show you an update on example projects we've been involved in. This is one of our flagship ones, a company out of Singapore,
Yep.
Robotics, and they're using MoveIt for bathroom cleaning, and it's a mobile manipulator. So we do a lot around whole body planning, as well as we've integrated Nav2, a package that everyone ROS knows and loves. But the whole body planning is important because if you just drive up and then park the wheels and then activate the arms separately, we actually didn't have the reachability we needed to do some of the cleaning tasks. So we actually have to coordinate the wheels with the arms to get that extended workspace. And we're in the camp, many people are, that humanoids are just this hype, and the true secret sauce right now and for the foreseeable future is wheels. There's a reason why we built our whole society around cars with wheels. They're a really efficient way of moving heavy batteries, and in this case, there's like a vacuum pump system on here, and all of that we think makes a lot more sense in a safe mobile manipulator platform. We are doing more around combining Cartesian planning with mobile manipulation. So we have this simulated world of an airplane hangar. Here's another example from that simulator where we're using actually 2 or 3 different models, ML models, to segment out the boxes, generate grass poses. And so we're combining a lot of complex systems into one. And so the bottom right, you see the behavior tree. It's looking pretty large there, but we have a lot of tools to create subtrees so you can have subsystems and reduce the complexity. And this is something that just kind of ships out of the box with MoveIt Pro now. So we're really proud of this high level integration. We do a lot with dual arms. So the next few slides will show that. Palletizing, depalletizing. You see it all over the shop floor to automate now, or the expo floor. But this one we're really proud of because it's actually doing dual arm control with a shared torso in the kinematic chain. So some pretty complex things there. Model control is a new feature that we've been rolling out, where we can do things like you see at Boston Dynamics, of like squeezing with forces a box and picking up something that's heavier than a single arm can pick up. We of course support 7th axis. So there's a linear rail here, not quite pictured, that we're coordinating different brand than the UR robot here. So combining different brands of hardware, this is all agnostic. One of the benefits of using ROS is that we can really mix and match sensors, different companies' actuators in a cohesive way. Here's an example of a basic ML model being used with bounding boxes to kind of help you debug and understand what the robot's thinking and how it's doing picking of objects on a table. Here's another example. So we do work with some pharmaceutical companies. And so this is an ABB Yumi and showcasing that we can control both arms at the same time. We are making progress on FANUC, finally having good drivers. We've been pushing hard on them. And I'll speak more of that moment, but that's something I really appreciate that ROS Industrial, particularly Matt Robinson, has been doing is pushing on that, as am I. So it's funny whenever I go to talk to these companies and really lobby for better ROS support, they're always like, oh, Matt just talked to us also. And so we have a couple customers now using FANUC, even though they've been a slower one. So a lot of people have been asking me, what about MoveIt 2, which is kind of the open source version of MoveIt. You can check out the website, moveit.ai. And it's still out there. It's kind of the original version. I think I have a version slide here. It originated as this ARM navigation project. Then there was MoveIt 1, which was just MoveIt for ROS-I. And then in about 2017, PickNik and some collaborators, we got it ported over to ROS-II, which was a big deal. It was a big jump because we were kind of early on converting it to ROS-II. But it was still basically the same code as MoveIt 1. So dating back to like 2011. And we just really, PickNik, we were like Dave Grant mentioned earlier, doing a lot of consulting with companies, and we kept hitting the same kind of bugs and limitations, like fundamental limitations in the framework. And so we were really struggling to overcome those in terms of funding it. And so personally, as like a technical expert who's really passionate about this, I'm just so excited that we've been able to finally rewrite and refactor from basically first principles MoveIt Pro. But I have it as a downward curve. I can't put it on the same lineage because it's not fully open source. Not much of it's open source at all, actually. Although it is using ROS throughout it, and we're contributing to a lot of open source libraries. So just kind of give you an update there is that MoveIt 2 is still totally out there. A lot of folks are using it, particularly for universities, for creating prototypes, but we also self-serving are encouraging if you have a commercial application for production systems, MoveIt Pro is that. So this is a little bit harder for me to share about like, well, what's going on with MoveIt 2. I've been asked to kind of hit on this. So we have kind of scaled down our involvement in a big way on MoveIt 2 maintenance. So it's kind of out of necessity. Just we're really focused on our limited resources on MoveIt Pro. We are really hoping to release what we're kind of calling MoveIt 3 one day, which is basically MoveIt Pro, but an open source version of that. We are still very committed to maintaining the website, the GitHub organization, and adding new maintainers. So this is a call to action, kind of like Kat was saying earlier, for the general ROS community. We are looking for more volunteers or maintainers, either from companies, from universities, who have sufficient background as a C++ code base to help us maintain this. So please reach out to me. There's contact information on the MoveIt.a website or on PickNik's website. We'd love to get you. There are a handful of folks still contributing, particularly our collaborators in Germany, and we really appreciate that. And yeah, reach out. So I do want to talk about other open source things we're doing. Quick update before we're out of time and get kicked off stage. But Space ROS, this is late breaking news, but just yesterday at ROS Industrial Dinner, I got a text saying that we won the next SBIR contract from NASA to continue Space ROS. So we're really excited about that. This is a phase 2, but started originally by Blue Origin and in collaboration with Open Robotics in its old form as a company. This is a version of ROS that is flight qualified. So we're not talking about this. This talks more about the automotive, but we do a lot with Space Force, with NASA, JAXA, Japanese Space Agency, a bunch of commercial companies. And so we're excited to see further usage of ROS in space. There is a lot of hurdles in terms of quality control because they're a little more picky about systems reliability. I would say too picky. Like ROS is reliable, don't get me wrong, but because NASA blew up some shuttles, Congress got involved and put a lot of regulation in, and it was a really sad event. Actually, I shouldn't be joking about it. So we are now funded to. This is the phase 2 to get the quality control up, and the great news is that we haven't forked ROS-II. We are just using a special like Debian distribution. I'm not even sure it's Debian, but there's a separate release that's a little more, gone through more rigorous testing, and PickNik's been co-leading that with some different volunteers from NASA centers. I hope NASA is still doing well. They've had some major budget cuts. But yeah, that's my update there is that ROS has flown already twice. I always have to clarify this. It was used on the Robonaut back in 2011, as well as the Astro B program. It's a floating, cute little robot in the space station. It's been used tangentially in lots of different NASA programs, but they typically, for the flight version, have had to remove it for like things like CFS, core flight software. But that's changing. There's a lot of people at NASA very interested in flying this, and so PickNik might be doing that. I can't speak to the exact missions, but it's on the horizon. And then the other thing I'm passionate about is hardware drivers and compatibility with all the hardware. And so, I have this line here. I just want to clarify that MoveIt Pro does use all the standard ROS things that you're used to. ROS packages, a ROS workspace, the DDS middleware. We can't wait to upgrade to Zeno once that's in the LTS. That's on our roadmap for sure. The logging build system. All of our configurations, the same plain text files you're used to, URDFs, SRDFs, YAML. So it's a very open platform, even though it's not as open source as maybe MoveIt 2 was. And you can still connect to things like Artist, Plot Juggler, Foxglove, whatever IDE. So there's a lot of things there that I think make us really unique. Most companies that are selling software for robotics have a much, much more closed ecosystem. And we're taking a very unique approach there because of our passion for ROS and our long heritage there. So MoveIt Pro has this runtime, but this is kind of the stack of things. And a key dependency below our runtime is real-time ROS drivers. And we need more of them. The good news is that there's already, I think, well over 50% of the arms I'm tracking. Almost all the major brands have ROS drivers now. It's a pretty comprehensive list. PickNik has personally made the ROS drivers for a bunch of brands. Some of them, we were paid by the companies like UR and Canova. Others, we had customers ask us to make it. And so we made it in collaboration with our customers, and we open sourced it so you can find them on our GitHub. And we want to do more. So one thing we did coming out of a ROSCon last year, and ROS Industry was there, we had Open Robotics and a bunch of other groups, is got this database online of hardware and their status. And so it's kind of like consumer reports, mostly for robot arms, but we actually have a ton of other categories. They're not as well built out, but we have all robot arms that I can find. If we don't, please send us a request. And it says not only is the ROS driver vendor supported, or is it community supported, or is it missing? It also gives it a quality score. So certain companies like Fanuc have low quality scores because of the control rates, the frequency we can command it at, the type of trajectory streaming that we do or don't have. And so the list goes on. We do have this rating criteria, great, average, and poor. So we're watching you if you release a ROS driver. We also have depth sensors, AGVs, AMRs, drones, force torque sensors, tool changers, you name it. As well as, like, if you want to build your own arm, we have components listed for that. A little less comprehensive database. If we're missing anything, there's a link on this website. Please submit it. We'll get it on within a couple of days to our web developer. And so in summary, MoveIt Pro fills a gap between traditional industrial automation and building a fully custom tech stack where you're having to like reinvent the wheel and like spend many years building out this thing. So encourage you to check it out. And my last thing before I get cut off is exclusive to this event, but also we did this at ROSCon last year. We don't do this very often, but we are offering free online training of MoveIt Pro. It's a hands-on thing, so you get to try it out yourself, download it. The next one's going to be May 28th. And again, we won't have these for quite a while after that, but we want to get some feedback and thoughts from the ROS community of how we're doing. So we're really love to, and I'll have QR codes back on the table as well if you missed this one. Thanks, Matt.
Thank you, Dave. And Dave.
Yeah.
We have time for questions.